Thank you. I do appreciate the invitation to come down and speak to all of you today. And my boss in Virginia doesn't let me out very often, so I'm happy to escape the lab and come to beautiful Florida. But big thank you to NFSTC for putting this on and NIJ for funding. And I got in a little argument with Debbie about this, and she insisted that I come down and talk. So I hope you find this talk interesting, but we're newbies when it comes to CE analysis. We've run gels for years, so this presentation is kind of what we've done over the past year in our transition to CE, capillary electrophoresis, and some of the trials and tribulations that we've gone through, and some of the bruises I've got from my staff back in Virginia. We had some questions that were posed yesterday, and I'm going to start off today with a question. We have a legal person who's coming here to speak this afternoon, and looking at the guidelines, about the first page or the second page, it says not to be applied retroactively. And how do we really think that's going to work for us? I've got a lot of questions about that. Are we going to get what's a judge going to look at that, and are they going to say, oh yeah, well, not to be taken retroactively, we're fine with those old cases you worked? But have other labs have issues? Have they been approached with court orders or reanalysis from old CE data for new CE? Has anyone seen that yet? New guidelines, new reports they want you to issue the new guidelines?
Brad, we had to go backwards in Australia when we made a major change. We had to look at a sample of 5,000 ancestral cases. That was absolutely debilitating.
Wow. And so if they change significantly, would you reissue reports on those types of cases?
We were completely out of control of the situation. We were dictated to by the Director of Public Prosecutions and the judiciary, so it could easily happen again.
So we've had some approaches to us in Virginia, and it's mostly, hey, this is FM bio data. We want you to redo it with CE. Does it change your answer, et cetera? And I've gone to court and testified on some of those, but we haven't had that situation come up yet. But I'm just kind of curious so be thinking about that, be thinking about your questions. Is everybody just still asleep or really haven't seen that? Has anyone not really seen that in their laboratory systems yet? So that'll be an interesting path for us in the future. But anyway, the NIJ disclaimer that we all have. Thank you for support. So we're going to be following the published guidelines. We're still working, getting ourselves there. We're not quite there yet. We're following many of the guidelines now, but we still have some more work to do. And we came here to see what things you guys are doing and what ideas we like and what ideas that we don't like, and that's not something we want to pursue. And that's fine. That's a good exchange of information. That's what these meetings are all about. We ran gels for years, and we were a big FM bio state, obviously, and we've been online with CE for a little over a year now. It's nice. It gives us a fresh start. It's nice that I get to call you and say, hey, let me have your manual, so I can cut and paste out of your manual, and it goes into my manual, so I do appreciate you guys sharing your manuals with me and that sort of thing. It's nice I have other people to go to questions for. We're the only crime lab system in Virginia. We're the only game in town. There are not other local labs, so it's good for consistency statewide. I have 4 labs, the main lab's in Richmond, about 70 staff. We do the data bank, we have casework, we have WISE, MITO, we're starting up familial, we're real close to that for searches, thanks to California and turning that loose. And we have a research unit, and they do most of my validation for me, so we're a lot of the work you're going to see here today. It's Susan Greenspoon. We let her out more. She gets to talk more at meetings than I do, so you'll see Susan and Katie Hall, 2 of our main research people that go to a lot of the meetings to speak. A little bit about the chemistries. We're PowerPlex 16. We have 3 different injection times that we use for our CEs. 5 seconds is our main injection time. And what kind of helped me with the manuals is considering the statistical approach at the end. And I think that knowing those ideas, it helped me write our manuals perhaps a little better. Many of our manuals are in some draft format, so I need to finish up, but it gives me an idea of where we're going with our conclusions. Can we and tailor our manuals accordingly? I was happy today that I have about 5 staff here at the back table, and if you hear them talking that Brad didn't take his medication today, or we're not really doing that in Virginia, or I don't know what he's talking about, they're all brand new examiners, so don't pay much attention to them. But I'm happy that we're able to share things. We have a random match probability like the rest of you guys do. We have been a big likelihood ratio state. We've done that for about 10 or 12 years. Typically we do likelihood ratios only on intimate mixtures. So it's a swab from the victim, and you're finding the victim's DNA and the suspect's DNA. That gives us a better idea of coming up with those 2 postulates of how the DNA was there. When we go to court, this is a mixture of the victim and the suspect, and this is the mixture of the victim and somebody else. And it's hard, there's not many changes to that scenario, so it's a very common scenario when we go to court. We're looking to expand that, though, into more all 2-person mixtures that we can deconvolute, that we would apply a likelihood ratio to those. And we'll do a CPI on all the other mixtures that we encounter. So 3-person mixtures, we would do a CPI on those, or CPE. And some of the things that we're going to talk about today. One thing that it really has taken us back, the FM bios are really workhorses, and it's a story in our Western lab. The water broke, and thousands of gallons of water poured into our FM bio over a weekend. And we unplugged it, and we dried it out, and the tech came out, and it was up and running within about 2 days. So we're very fortunate. We didn't have to do a lot of repairs, but the CEs is completely, and you guys know this already, it's a completely different beast. They're very temperamental, and we've already had to replace 2 lasers. So this middle bullet here, what happens when we apply these thresholds, when we repair an instrument? Are we going to have to go in and recheck these thresholds? And we've had to do that or try that a couple of times. So I'll give you an idea of what we do, and you can share with me what you guys do as well. We looked at limited detection. We had 3 different injection times. There was no, we were concerned that, oh wow. Very nice. We were concerned that we would have to have limited detection for each injection time, but we checked this at the multiple injections and it didn't change. So we were happy to have that, see that. We have 9 instruments, and we go with a statewide average, and we'll recalculate that. And Mike Coble was talking about how to set up your limited detection, so I'm not going to spend a lot of time on that. We do 2 times max noise, and we do it per dye, so it changes per our different dyes. We have our thresholds set, blue, green, yellow, 73, 84, 75, and red, 52. Red's the internal lane standard, and we don't really care what that is for the internal lane standard. The examiners can change that threshold if need be. So evaluating the LOD yearly, and we're going to do this for a couple years to see if these values truly change, and then reconsider if we have to do this all the time. We will recalculate the LOD. We will look at all different types of samples. We don't look at just reagent blanks to calculate that limit of detection or that analytical threshold. We'll also look at positive controls and evidence samples. 2 times your max noise, we'll have a statewide LOD that will apply. And if we get a new laser or something like that, we'll recalculate that LOD for that instrument. So we've done it for a year, and in January we came in to recalculate the LODs in Eastern. We have a lab in Norfolk. They're always challenging to work with. Everybody has those labs or staff, but historically very low LOD in the Norfolk lab. And the first time we tried this, we had multiple examiners working on this. One examiner would analyze samples from one instrument. One examiner will analyze samples from another instrument. Hindsight, maybe that wasn't the best approach. Maybe we should have all the data sent to one examiner who will measure it for all the instruments. Is that a better approach to this? It's something similar we did with the FM bios. So the averages are pretty close to, at the top is the average LOD, what our current settings are. So the averages are pretty close. We're going back in and reevaluating the Eastern data. But we're trying to establish a quant cutoff. And everybody knows your quants are estimates of, and they can vary quite readily. And what we've seen, the validation suggested in a 30 to 50 picogram range, we're seeing a lot of dropout and a lot of complete allele dropout. And then we're testing this on real casework samples. So the idea is we would stop the quant for certain types of samples and we wouldn't go forward anymore with the DNA testing. Can we avoid stochastic thresholds because we're at an area that we can't get the results that we need to move forward with this? Will this be a more efficient way for us to process cases? And then we apply this at multiple labs around the state, looking at the robot runs, collecting that data and seeing if you have just what you'd expect. If you have quants that are below this, are we getting any usable data out of that? And it's Plexer. We use Plexer, and it seems to be more reliable at the lower end. After you get more DNA in your sample, it can vary some. So we've been happy with the reproducibility at the low end of that. More about Section 2 of the SWGDAM Guidelines, pretty much straightforward. Section 3 is where it starts to get interesting. Staff remind me the gels weren't so bad. The one thing what's great with the CE data that I think a lot of people take for granted is that we can email this data around very easily. So it's easier to get your examiners on the same page. You can take your mixtures, you can make examples of these mixtures and send them to your staff. They can reanalyze these things. It's very difficult to do that with the gel images to do that. So it's a part of getting all of your staff there on the same page. We find that very useful, that we can send out the same mixtures, everybody examine them at the same time, and we all come up with consistent results. Non-allele, so we have examples, obviously, in the manuals of the non-allele peaks that we remove. You guys probably have all this too, but if we have pull-up, we have good examples of how to get rid of bleed-through or pull-up in our manuals. We still can't get away from gels. We have some people who still like to run gels, so this is a product gel. This is actually MITO data, but if we have off-scale data, we have some options with off-scale data. People can run product gels in their data beforehand, and then they can determine what their injection time is going to be from this. So if we have a lot of people lined up waiting to inject their samples, and we can't do re-injections very readily after that, they can run their samples on a product gel and know that, hey, we're going to do a 5-second injection or a 2-second injection. So I think it's something that's fading away. I think those people just wanted to have some more gels in their life. They didn't want to give that up completely, but we still have some diehards that will use gels to figure out how much DNA they would like to inject in the machine, and it works well. So then we set out, we had our analytical threshold determined, and we wanted to get what would be our stochastic threshold. And so we had 2 samples that were heterozygote at most of the loci. One person was a homozygote at one locus. Paul Farrar, he is our old department director. Most people know Dr. Paul, but he's a heterozygote at every locus, so he was happy that we were using his sample. We looked at 10 picograms, 30 picograms, and 100 picograms. And then we requanted those. We did dilutions to get to that level, and then we requanted those dilutions to make sure that we were close to that. And we were right on the money. And then we made 10 replicates of each. We amped them all together in the same thermocycler. And Mike called these different. These are really called blister plots. Mike wasn't correct when he called this a burn plot yesterday. And they took this data from us. I mean, we came up with blister plots, and Mike and his person, John, had some of that data that they wanted to use. So it's a lot of information on the screen. It's the same color scheme that Mike had yesterday, or similar to that. Yellow denotes that we have allele imbalance past the 60%, If it's a star, yellow with an asterisk, that would mean that we have lost that allele completely. Red would mean that we have a complete locus dropout. And so you can, the 30 picogram range, you obviously see more red there. And it's remarkable. It's a very similar scheme that Mike had yesterday, so it all behaves, even though it's a different kit, different lab system, it all behaves very similarly. So we took the averaging the RFU values of the surviving sister peak, and when the other sister peak fell below the LOD, we added a standard deviation. And then this is the part that the staff, this helped more with the buy-in of this, is that, we talked a little bit about it yesterday, is that we use pristine buccal samples to determine this. And now, is this really applicable to the mixtures that we see in casework and the casework samples that we see? So we go to the staff and say, all right, send us your awful samples, your difficult samples. They have to have reference samples with them so we can kind of evaluate, do we have allelic dropout or not? And then kind of test our stochastic values with those of casework values or casework samples. And so we've come up with our stochastic thresholds, and they're very similar to what other folks in the community have calculated. 230 for 5 seconds, 330 for 10. The 10-second one, I'm going back and reevaluating that just a little bit. I've talked to some other folks in Maryland. Theirs was a lot higher than that, so I just want to make sure we're on the same page with the 10-second injection. But you still have to use your discretion when looking at these mixtures. It's a predictor that you can have, but you're still going to have data that violates, or you're still going to see dropout of some of your samples, as we all know. Todd was showing some examples yesterday where you have masking that would occur. And 2 examples of masking that there are lots of others out there, but just to share with you. The reference is a 12 in the top and well above the stochastic threshold would be in this area. So at the other areas of DNA, you can see that you have a low-level contributor that's at that stochastic level. And its reference value for that contributor it's like a 9, 12. Absolutely no sign of that 9 there. So you have to be careful. You have to obviously have a very broad interpretation standards that can encounter or can account for this when you're interpreting these types of samples. We will try to so obviously we have some other data that's showing up here, more dye blobs, not really a good peak morphology. But we will try to interpret, not really, to interpret's the wrong word, we will look at that data beneath the analytical threshold to try to get an idea of how many contributors we have. Especially when we have a low-level contributor that is right above that analytical threshold. Could there be, since we're a likelihood ratio, we have to make assumptions as to how many contributors that are in those samples, so we would have to take that into account for that. A similar example at the bottom. So again, it's always challenging to write your interpretation manuals with enough flex in them to account for these types of situations. Peak height ratios, we actually publish our lower limits. Our manuals, we put all our manuals online, so they're all published online. You guys are welcome to go look at the manuals, or if it's not what you're interested in, obviously you don't have to check the manuals out. You could take it, if you like report writing from the manuals, you guys are free to use report writing what you see from the manuals there, but they're all Virginia Department of Forensic Science. If you'll Google that, they're all published online. So, struggling when you have these real complex mixtures to figure out how many contributors you have at those in those mixtures. We get a lot of touch DNA evidence. We've had, can we avoid stochastic data? And what we like to tell some of our user agencies is we'll meet them downstairs when they submit the evidence, and we'll say, hey, there's this really good lab. It's about an hour north of us, and there's this tall guy that works there. It's an ATF lab. And if you have touch evidence, he'll be happy to work that at his lab. And he has a 5-day turnaround time. And that's a very popular thing that we send all our stuff to the ATF. But we're not that lucky. We have to deal with it just with you guys. It's the same. We get lots and lots of touch evidence that comes in. We get stuck with touch evidence that comes in, and it's already gone to fingerprints, and it's already gone to firearms. They don't wear gloves, and it comes to DNA, and we absolutely have to process it. So we're finding the firearms examiner's DNA on the weapon. So major, minor, trying to sort this out with major, minor. We try to limit this to 2-person mixtures. We have a 33% cutoff that we'll use. And the question has come up, will we call multiple majors or minors? And that's something I need to go back and look at a little carefully. Yeah, I don't want to have the additive effect of all those minor alleles, and they have a common allele or allele sharing, and now it shows up as a major and kind of fool us with that. So I'm going back to, can we call 2 majors or 3 majors in a mixture when depending on the heights of those minor alleles? And it's not something we have done a lot. This was an interesting topic, and it was a topic that I think my examiners had a lot of passion that they like calling their stutter, and they didn't want to consider it a real allele. And when you sent this email out, instantly there's a line outside your office saying, wow, what were you thinking? Was there a typo in that email? You really want me to consider that these are actually alleles. I know they're stutter alleles. So this has been some work, and you might have seen the same type of situation in your laboratories. But we'll simply compare the smallest minor to the largest stutter. So in this situation, obviously your minor allele is beneath your stutter, and so we would use those stutter alleles. If we did a CPI for this, we would use those stutter alleles in that calculation for this mixture. And always questions, so how our examiners would do that, they would go in, if they had that situation, they would turn off the stutter filters for GMAP or ID, reprint out that data so the stutter's called, and then they'd actually highlight those alleles or circle those alleles that these are alleles we're going to use in the CPI, and then send that data off to their tech reviewer to review. Does anyone have a similar approach, or are people doing peak height ratios to consider their stutter alleles? Or people don't want to consider the stutter alleles? So at some loci, obviously we have some minor contributors here, but everything at VWA is called stutter. And so we would evaluate the minor contributors at the surrounding loci if we can. And again, so this is pretty close to being smaller than the large stutter there. So we would go ahead and consider the 2 circle alleles, these alleles, into our CPI calculation. So that's how we would handle it when there are no minor alleles at that locus, but there are visible stutter alleles, small stutter alleles at some of the other loci that are below that level. Evidence prior to references, that interesting concept. We've all done that, but we all process evidence, I'm sure, the same way. And what happens, we don't look at all of our evidence before the references at the very end of the case, if you think about it. And you guys are probably the same. And so if we have a PERT kit that comes in, we'll find sperm in a PERT kit. We're not going to go to the bedding, and we're not going to go to the clothing. So when that sperm comes back and it matches a consensual partner, and now we have to go to the bedding or the clothing. So obviously to the extent possible, we'll look at the reference samples prior, well, the other way around, we'll look at the evidence samples prior to the reference samples. The questions have come up to us, are we going to have, now that we've seen these reference samples, are we going to have another examiner process the bedding because they've seen what the reference sample results are? And no, we have the same examiner process the bedding in those samples. We just simply wouldn't have when you're sizing the other evidence that comes in or that subsequent submission, we wouldn't have that reference sample, sitting right there on your desk. And it's up to the examiners to ensure that they wouldn't do that, and I'm sure they wouldn't. But I imagine you guys are in a similar situation. Does anybody reassign? Some people are advocates of reassigning that evidence to another person to examine. Does anyone practice that? No. For years with gels, we couldn't take advantage of expert systems, and now with capillary electrophoresis, expert systems are there. So what we're pondering is, can we get an expert system to work with the reference samples? We do robotic extractions for everything that we have. Can the reference samples take a completely separate path in the laboratory, and the expert system work on what those allele calls are, and then once we're ready to go to the reference samples then and compare it to the evidence, take that approach. Would that be more efficient or not? And we're looking into that. We don't know what that final answer is, but so a number of things you guys know already. We like to test all the validation you want to do on your samples that you make up in the laboratory is a great idea, but we also like to try to test that on evidence samples as best we can. It helps get buy-in from your staff. And a little bit on some of the mixture interpretation. We're going to be talking a lot about deconvoluting mixtures tomorrow, so I'm not going to spend a lot of time here. Historically, we would do all this data is above our stochastic threshold. So historically, we would have done a CPI on all of this. Now we would try to do a two-person mixture. We would try to go in and do a likelihood ratio. We're interested in trying to do a likelihood ratio with a dropout factor, so we're interested to hear the speakers this afternoon speak about that. One thing that we haven't really taken a lot of advantage of, and I don't really know why we haven't done this, but it's something we're looking at more. Can we subtract out, if it's an intimate sample, can we subtract out the victims' knowns? So that would be the one exception where we would process the evidence, obviously, and we would get the victim known right after that and compare that to the evidence and look for the types that are foreign to that victim. And it's something we haven't done a lot. We would just do a mixture statistic on that. But now, with these guideline changes that have come out, that's something we're exploring more and more to do. Can we subtract out and then just do a random man statistic on what's left over? If we had a single peak that is below, so we did the random man statistic or calculation, we had a single peak that's below our stochastic threshold, we would treat that with a 2p calculation. So that's the easy one. We go through these. These don't get questions outside of my office very much. It's a very busy position, 70 people, all different. I'm the only tech lead in Virginia, so these cases I like. These cases, wow, I get some headaches on these. I spend a better part of my day trying to work through these types of mixtures. And it's, what can you do with this data? And we're looking at an upper level cutoff. And Todd spoke a little bit about that yesterday in his presentation. But if we have 7 alleles at a locus, are we really going to be able to draw conclusions on that? You have 7, 8 alleles, 9 alleles. Are we just going to put a cutoff and say, hey, this is data that we can't use. It's too complex for interpretation purposes. Is there another piece of evidence in the case that can be used? Is there other forensic evidence in the case? Do other labs practice that? Or you're trying to interpret all mixtures, no matter how many contributors you have? No, yes? So, guys are a quiet bunch. The stochastic threshold here, obviously with doing a CPE stat, we would not be able to do stats for these loci. We would try to use it for elimination purposes only at that point. We wouldn't, we're trying to do those calculation or those interpretations at loci where we have at least one allele from every contributor. So The two circled areas, obviously, I would think that we're missing one allele from at least a lot of dropouts going on there, so we wouldn't be able to make conclusions. We would not be able to perform any eliminations. No one would be eliminated at those loci. So in this example, we'd use that one locus D8 plus the other locus that loci that are not shown here for that. And is anyone similar approach, very different? Talk to me after the presentation. So we're looking at a peak-high ratio. We're doing in Stutter at the low end of data. If you're down to 50 picogram range, can we go in and reanalyze that? And what are those peak-high ratios at those areas? Percent contributor to help deconvolute the mixtures, a quant cutoff, probably in the 30 to 50 picogram range. We're considering a mixture cutoff at those really complex mixtures. If you have 7 or 8, if you have a 4-person mixture, can you really deconvolute that? It looks like ladder basically. Are we wasting our time with that, trying to roll through that? We're interested in a likelihood ratio with a dropout factor to try to harvest some more statistics from this data that is in that stochastic range. And what expert systems can help us with this? I know that New York is looking very heavily at that. Can it aid the examiners? Can it also be a path for all the reference samples that would make a more efficient analysis and limit any bias that may be there in the laboratory systems? A big thank you to acknowledgments that I failed to put in here. Susan Greenspoon has been putting up with me at the lab and doing a lot of the validation. Katie Hall has also done a lot of the validation work here, and all my staff back in Virginia. Contact information, come see me after the meeting, or you can send me an email. I would be happy to talk to you. Any questions that I can answer? All right, thank you very much.